Good afternoon or good evening to everyone here. So, me and Pugazharasu are going to just talk about the basics of LaTeX. So, first, small word here that this is not an exhaustive list of everything that says there on LaTeX. This is like a very, very elementary, like to get you guys engaged in LaTeX. Okay, so I'm not going to go into much depth here. So, the abstract here is this tutorial will provide a quick guide setting up and using LaTeX. And as we all know, it's a very popular framework that is used widely in science to create scholarly and official documents like research articles and even books are written in this LaTeX format. So we have divided this tutorial into two sections. So me myself, I'll be talking about the basic language that we use in LaTeX and how we go about structuring LaTeX and the basic commands, and then Google will follow up with a practical use case scenario basis of all the specific articles and Beamer templates that are there. And then he will also be talking about a very important aspect of bibliography. As you know, when if you want to pursue in academia, you need to know how to properly cite and use bibliographies in your research articles and books that you publish. So without further ado, let's start off with motivation. Why LaTeX? I'm sure all of us here, as of now, know what this LaTeX is. It's essentially a programming language that is essentially used to make research and mathematical documents that is usually not present in, let's say, Word or other text editing documents. So and that essentially gives us the window to why LaTeX. Because if you want to put, let's say, very complex equations, or let's say, we're going to see as we go on about more complex diagrams such as Feynman diagrams or circuit diagrams, we can actually embed in LaTeX itself. And I'm sure, I think soon, Google might also show you an example of an excellent article. I think we've already done a lecture on that on differential geometry. The thing to note in that paper is that that paper is entirely made on LaTeX, and then every let's say every diagram and every table, everything is just constructed on LaTeX. So it's not just writing equations, because even in Word there are certain there is, I think there's an option for you to include equations, but then that is not just what LaTeX is about. So we are going to explore that in this talk. So getting started with LaTeX. So how do you get about? So you don't just directly just download this Text Studio app and then just start typing out. No, it doesn't work like that. So first of all, is my browser visible? Anyone? Yes. So this web, we will link all of the websites here later on. So then this Text Studio website right here. This is where you download your text editor. Okay, so then you essentially download this Text Studio installer here. You install to get this app right here, the application. It's not a huge download, so it's a pretty light download. But what might be a bit of a data hogger if you're on mobile data, most of us have Wi-Fi, but then just putting this out there, this is the MIGTech repository. So essentially, this has all the packages that you use to compile your code in Text Studio. So this is the editor, while you need MIGTech for all of your uh, packages that you use. So then here you have one for Windows and for Mac and Linux. Then you can essentially download this around 240 MB, and then you might need more data to update your packages. So this right here, this is your MIGTech console. And essentially, when you download MIGTech, I would recommend that you check for updates. I have not done so. I don't know why, but then it's highly recommended to check for updates. And then when you look around in the internet, let's say for specific use case scenarios, or maybe we'll see in this presentation that how to use Feynman diagrams and circuits in LaTeX. So then you can essentially check up your thing. For example, let's say Feynman diagrams, or wait, it's called V, yes. Definitely filter for C. Yeah. I think I already have that, so it's not appearing. So then you essentially look up the package that you want and you can just install it here. And there are various packages. So yeah, so let's get back to our presentation. Now that you've installed that and Text Studio, you essentially come up here. Right? So, and then we wander into the basics. So how do you essentially get started with an article or a beamer? So I will link the presentation for the beamer. I think Google will take a much more deeper look into that. I'll skip on that. But then what I'll mostly focus on is the very basic structuring. So at the beginning, you need this uh, what do you call this? Called the preamble. Okay, so I think the Beamer has a much bigger preamble here, but this has just your document class, and then in uh, curly brackets you have articles. So this essentially defines the document class that you're going to use. Okay, so and then this is your title and author. You essentially just type in your name and your title. And how we use here is we use these backslashes here. That is key here. Any command or any operation you want to do, you essentially start with the backslash. So here we have our backslash begin document, and any beginning needs to have an end, right? So then it will just be an infinite loop. So then we have the end document here. So essentially we have your beginning and your ending. So what the neat feature that Text Studio has is essentially if you type in begin, it shows their environment name, and then you can just type in document and it finishes it for you. Right. So then one thing here, you can't use two begin documents in the same page because that will probably cause some issues. So then, yeah, that is your begin. This essentially begins your environment, your document environment, as we call it. And here we have our abstract environment here. So then your abstract environment, let's say, has specific rules for rendering your text. Okay, so then your section plus subsection, these aren't environments as document or abstracts. This is just, let's say, text formatting. So let's say your section and colon, your text here will make your text look big, and your subsection has makes your text look smaller. And another thing to note here is that um, this section plus subsection also helps a lot in making your what you call table of contents as we see in our LaTeX Beamer here. Again, not to be confused here, I think Pugazharasu will go into a much more detailed uh, explanation of all these separate articles and Beamers, but then let's just go into the basics. So yes, as I said in the beginning, mathematics is the entire uh, core of LaTeX. So yeah, math. So let's start up with how to insert equations in LaTeX. So then there are multiple ways you can insert equations LaTeX. Just 1 second, Google. Yeah, it's visible, right? So yeah, let's go into how to insert equations in LaTeX. So please feel free to stop me wherever you want me to stop. Okay, I'm not gonna take this personal or anything. So then yeah, how to insert equations in LaTeX. Okay, so how I'll go about with this entire small tutorial of mine is I'll have my PDF open on the right side here, and then I have my all of my code on the left here. Again, do not be intimidated by all of this. The template itself. Okay, I'm not some like they show in the movies. It's typing non-stop and stuff like that. No, no, no. This is an entire template that I just took from the internet. So I'll link that template as well, so you don't need to worry. So as far here, how to insert equations. So first of all, we use this thing right here, the dollar symbol. So we can see in the left side here. So the dollar symbol creates the math environment. And here we have so the time independent loading and wave equation is comma. We have our dollar symbol here. So the dollar symbol essentially creates a math, let's say mini math environment. It's not a complete one, but then you have a small math environment here in between our text. Okay, so then if you do not use this dollar sign, mind you, you cannot use all of these math commands in here. For example, backslash psi is a math command for our psi here. So you cannot use this without a math environment. So for inserting equations or any symbols, you need to have a math environment. Okay. So then the double dollar, what that essentially does is it gives you a math environment below your uh, uh, text. So then we have here the stimulated rate of emission is given by, let's say there's a double dollar sign here. So instead of being in line with your text, it essentially gives you a space and then it gives you the equation below. So you don't need to know any of these equations. So I just put this here for a reference or just as an example of how to use these equations. Yeah. So we are continuing with our math environment. So there are plenty of math environments. So the first one is the equation environment, that's the align environment, there's the multi-line and gather. So each of them have their own specific use case scenario. So if you just want a very plain equation or just a normal equation, a numbered equation, you can use the equation environment. The equation environments right here. So we look, if you see here, we have our begin equation and our end equation. So this asterisk right here, what that essentially does is it doesn't number your equation. So if I remove this asterisk, what that does here is it gives you a number. So let this render out. Yeah, see, we are getting a numbering here. So let's just leave the asterisk there for now. Yeah. And while I render this, let me just give you a quick overview of the toolbar here. This is your new file. This is print, save, and this is your exit, undo, redo, and this pretty basic stuff here. So I want to focus on these two here. This is what you'll probably find new. So then the play symbol here is just compile the code and then not give you an output. But then this is called the built-in view command, or the shortcut here is F5. And if you do this, it essentially builds you the entire PDF and then previews it here. Okay, so next up is the align environment. So let's say if you want a multiple equations like this, so for that you need to use the align environment. So yeah, begin and end align as usual. And then if you see this ampersand here, this small and fancy and here, this is called the align tool. So then right here, what this entire equation tells here is it tells these ands right here tells us to align here. All of the equal to's are aligned here, you see. And that's why I have the ands before every equal to sign. And then the ands in between essentially aligns this empty space here. Then that is how you use your align environment. And this is the multi-line environment. Okay, so this is another thing. And what you use here is you use this double backslash. Okay. And when you use this double backslash, what it essentially does is it breaks your long equation here because it wouldn't obviously fit, right? If you just have it on one long equation, it won't fit. So then you use your multi-line and then you use a double slash and then it essentially shifts your equation to one space below. And then the gather environment. So what do we use the gather environment for? It's very similar to the equation environment, but then here what essentially is in equation you can't have multiple equations in the same place, okay? But in gather, it's a more neat way or a less neat way, the way you look at it. Then I can just use this backslash, double backslash here, that is the new line command. I can just use this double backslash here to create, I don't know, an infinite number of equations without, separately going begin end equation, begin end equation. So if you get what I'm trying to say. Then these are the math environments. Okay, so then these are the basics that you need to know. I think mostly you just need to know the equation environment. I use mostly the equation environment, and if I need, let's say, to work with matrices, I use the gather environment. The align environment, mind you, it might be a bit messy if you don't get the spacing right. So then, if you have any doubts, just search it up on the internet, and you'll be fine. How to format it correctly? Because if you mess up the spacing and the and aligning here, right? So then, if I expand this, I think you'll probably know. Yeah, see how these ands are exactly aligned here. If you miss this and spacing, this entire align environment goes wonky. So then I tell you to take care of that. So those are just some small things that I do personally. I use the environment the equation and the gather environments. So any questions so far? Quickly, anyone? No questions? So okay, let me just go on. So yeah, let us move on to the next topic. That is subscription superscript. This is very simple. You know how our subscripts work. So the basic syntax is so X power and your this upper power that you use, and then this underscore essentially gives you the subscript here. Okay, that's very simple. So conjugating subscripts and superscripts. You can see here that essentially what I did here is I put one underscore and one to the power. So essentially what it does is a underscore 1 to the power 2 gives us this output here. So it has like, let's say we need this in tensor notation and all, you might need multiple subscripts and superscripts. And then, yes, here, the another very important thing, very crucial thing, when you're subscripting, it's, let's say two or more numbers or two or more alphabets in your subscript or superscripts. It's very essential that you put it in this curly bracket right here. Okay. Because if you don't do that, what it essentially does is it only takes 2 as the power and then just ignores your alpha, and then the alpha will just end up as a normal uh, coefficient right there. Then if you see here, we are using our curly brackets here, x power 2 alpha, we have it there in curly brackets, and yij and yij is also there in curly brackets. Okay, that's very important. Okay, because why I'm specifically focusing on this is because when you're rendering this, right, you get a lot of errors if you see. And then those errors really do not tell you a lot. And they will just tell you like, see, there's an error in this line here, but then it will tell you stuff like, document not rendering because that, and that doesn't give you a lot of information on its own. So then if it highlights that you have any problem there, it's mostly because you have something to do with your curly brackets or as we go on, we'll see why this might be a bit tedious to work with. So we have our behavior of subscription, superscription operators. So this is a summation operator right here. So essentially, backslash sum and underscore I equals to 1 power infinity. Okay. Then we can see what the powers the if you for the underscore, what it essentially does is it doesn't power. It doesn't give like sigma to the power something. It essentially puts the infinity and the I equals 1 at the top and bottom. So essentially, you have a complete summation convention right here. And then same with the product also. Underscore P is underscore P right there. Yeah. Product underscore P gives you the thing right there. Okay. So I think that is pretty done with. And the next up here is syntax for brackets. So brackets, parentheses is pretty simple. You just use your normal parentheses, your square brackets, your curly brackets. One thing to do with curly brackets is, if you remember, the curly brackets is for defining environments. If you want to use the curly brackets, you need to use a backslash next to the curly brackets. Okay, so just keep that in mind. And then one thing to note here is that if you just, let's say, if we take a look here, we have f is equal to g, and we don't just use the brackets here, because if we do not have this left and right delimiters here, we call it. If you do not have these delimiters, your brackets will end up just looking very small. So I'll just show you how that looks quickly. So without these delimiters, your brackets end up looking like essentially, just a second. Yeah, essentially like this. This kind of doesn't look neat. So then that is the entire point of using your delimiters, your left and right. And I think your text studio has a command right here. If you type in left, it shows here either whether you want a square bracket or a curly bracket. It shows it. So then you essentially use this. So the left and right parentheses, and then you type in whatever you want here. Okay, so that is why text studio is very elegant, because you have very less work to do. You can just type in whatever you want and then it just autofills it for you. I did the same for our square brackets and angular brackets. Okay. So then matrices. And how we essentially define matrices are we use this. We first define a math environment. Either I'm using gather here. Okay, you can also use a begin equation. It just personal preference. And then if you see here, we have a begin colon matrix. So the matrix itself is an environment. Then you essentially use the ands to separate the vertical, so the horizontal indexes, and then you use your next line thing to essentially insert a line break. Okay, so that is pretty simple, I think. If you take a look at this again, you'll probably understand how it's done. And then there are simple things like, let's say, P matrix is for your parentheses matrix. B matrix is your square bracket matrix, and same thing with curly and everything. Okay. And then your inline matrices are simply you just type it out, and then you just define a math environment, and you can just stick in your matrix right there, and it just appears like this in your text. Okay, so now we are moving on to fractions. So I think this is very key here. Matrices and all, you don't need to take much note because I don't think you would come across much matrices. But then fractions is very, very key here. So then the fraction is essentially defined by this thing here, backslash frac, and you have double. Uh, so if I have frac, okay. If you see here, yeah, you can see here that it says backslash frac. The first thing essentially is the numerator, and the second thing is the denominator. Okay, so we can see here that a fraction n factorial, and this is the denominator, that is the k factorial n minus k whole factorial. And the binomial thing right there is essentially the same thing as frac, but instead of backslash frac, you use backslash binom. Okay, and nested fractions is you can essentially just nest fractions and just can keep going in an infinite loop. It doesn't matter. So you can just nest fractions within fractions. So you don't need to worry about that messing up your entire document. It can be done. Okay, so then I think we are done with that. So next, operators in LaTeX. So there are a lot of operators. I'm just gonna talk about the limit operator. Okay, so the limit operator essentially is defined in this way. So backslash lim and underscore h to 0. Okay, this is essentially, you can take it as you're just typing lim and you're giving like a subscript to it. Okay, so then this f of x, this is the first principles right there. Okay, and this is a bit more advanced. You're declaring your own operators. Okay, so this thing right here, this RTG isn't a normal operator. Okay, it isn't readily available in the AMS math package. But then what essentially I did is, you see here, yeah, right here, I'm declaring this math operator. Okay, if you have any doubts about this, you can essentially just look it up at overleaf.com. Okay, so this is essentially how you declare a math operator. So you just declare backslash RTG to just be RTG. Okay, so this is this is the syntax you use for declaring any math operators, any custom math operators that you might use in LaTeX. And we come up to spacing. So let's say if you want to leave, a space between x squared. I think I used a space here. You might have noticed previously in one of those equations. So how does this entire spacing thing work? And yeah, I'm using an align environment here, for aligning all of my equations elegantly. And I use the ampersand before the equal to. And as I said before, that essentially aligns all of your equal to signs like that. And then if you see here, this is called the what do you call the spacing operators right there. So you have the backslash factorial, or what do you call it, exclamatory mark, and then that gives you the normal spacing. And then right here we can see here, this one is the backslash and dot, and the colon, that gives a bit more spacing. And then as you go on, you can go on to the colon, semicolon, just a backslash, and this q quad essentially gives you this huge spacing right there. I don't think I'd ever use this, but then it's there just to show you the spacing delimiters that are available in LaTeX. Okay, so now we come up to integrals. Integrals is pretty simple. You just use this command right here, backslash int underscore. So as I said, this is also treated as an operator. So if you have underscore a, that gives you the subscript, and superscript b gives you the upper limit. So this is how the entire integral of operator functions. So then there are multiple integrals here, the double integral, the triple integral, and then the dotted integral. There is also OINT, backslash OINT, that is your closed integral. Okay, but I haven't included it here. I don't know why. So let us go on to sums and products. So I think I previously showed you how sums work, right? I think for our operators, no, I showed it in our subscript and superscript. Same thing here. You just use backslash sum, and then your subscript gives you the under the summation thing, and then your superscript gives you your till what to sum to. And then the same thing with products also works the same as your sigma right there. And we move on to math fonts. So then there are many examples of mathematical fonts right there. So there is math normal, there is math NRM, that is the math normal, and there is the math IT, that is your italics right there. And you have your BM, that is your bold math. And you have all of your equations in bold. So then if you want to just give a bold uh, font to any one of your coefficients right there, you can specifically do that with the BM font. Okay. So we saw that the previous section was really dry, just using a lot of equations. So how do you make LaTeX non-boring? Right? It's simple. As you, let's say, a PowerPoint is used for a lot of pop science things and stuff like that. So how do you do that in LaTeX? So we use our thing right here called the figure environment. Okay, so we can see here this is called the begin figure. Okay, we essentially begin figure and end figure. I'm using here, it's called the centering. So essentially centers the figure. And this right here, the include graphics thing. Okay, so then for you can't just include any figure. Okay, first you need to save your images in the same file as you save your LaTeX file, and then you need to have this in your preamble of your document. So then, yeah, you need to first of all use the graphics thing, use package graphics X, and then you need to specify your graphics path. Okay, so whichever path your all your images are in, you need to specify that with this command right here. So graphics path colon, and then I saved it in dot slash images. You might have it in your different folders. Okay, key point there is it needs to be in the same folder as your LaTeX file, or else it won't work. Okay, so and then once you've done that, once you've saved your file in your LaTeX folder, you can just use it include graphics thing right here, and then this essentially scales your figure. And this is a very high quality figure, so then I scaled it to 0.2. Okay, and then this is your file name. So essentially, whatever file name you saved it in your uh, images folder, you use the same name here. You don't use the extension .jpg. You don't use. You just use your normal name that you saved your file in. Okay, so tables in LaTeX. Okay, this is a bit more. Let's say it gets a bit more advanced here. You might not remember all of this. Okay, so then I highly recommend you go take a quick look at overleaf.com. It has all of this information. Okay, so how do you make tables? So we use a begin tabular format right there. So then this thing right here, see right there, I'm separating that with a word line. So that essentially tells this environment, see there is a line right there that you need to input. If I don't use that and just put three C's, there won't be this entire line right there. Okay. And then essentially if you see and then the next example, I'm essentially defining the lines also. So horizontal line, horizontal line. So this H line essentially is this horizontal line right there. Okay. And then we can see another thing we did is we use a double word here between our seats. So that essentially gives us this border right here. Okay. So next we wander into diagrams. So this is something I learned today. I just stumbled upon this. So I'm not very adept at this. So this is like you can actually draw stuff in LaTeX. So like I'm sure we've all drew in like turtle programs and stuff like that, right? So I think this is something similar to that. You need to learn the syntax and all. I just put here to show you that it can be done. You don't need to like just attach some images. You can just draw simple images by yourself, native diagrams. So this is again, it's in the picture environment. Okay. There are tutorials about this specifically. I highly recommend you to take a look at that. And this is a more complex example that I did. So this is essentially a what is this thing called? A tetrahedral triangle, or what do you call that? Oh, I forgot geometry so quick. So yeah, so then you essentially define your same picture environment, and then you can see all this code that's gone on here. Personally, I won't bother myself doing this. I'll just screenshot it somewhere and then just stick it into my images folder and just include images. But it's cool that you can draw stuff natively in LaTeX. So then this is a bit more advanced thing as the previous one. This is called the TXZ package. So what does the TXZ package do? It's essentially one of your packages that you define at the beginning again. So if you see here, I'm using the use package TXZ, and then I'll show you what this circuit TXZ and Feynman's are next. This essentially lets you draw like more complex diagrams instead of just lines. And then we can see here, we can see the TXZ picture environment, and then I basically just copy pasted this, so I'm not so sure about what this all does. I just put this here to show to appreciate the various packages that are here in LaTeX. I'm just going to be honest. Okay. So next up, we come into more advanced LaTeX. Okay, what do I mean by advanced stuff like this? So this is called the circuitic package. So this is another package that you can download, and this essentially lets you um, draw circuits in your LaTeX files. We can see here how they essentially draw the entire thing. I'm not so sure how they do this, but I'm open for questions, and we can probably work this together as in how we can draw circuits. Like we can have a session on that separately. And then I'll end this with another cool example right here with the Feynman diagrams. I'm pretty sure most of us know what Feynman diagrams are, but then we can see here that using the correct repositories and packages, we can also incorporate Feynman diagrams in our LaTeX files as well. So then my bit ends here. I will head over to Google. But then before I end mine, I'd just like to make again a small disclaimer or a tip for all of you is personally from my side, while I was learning LaTeX, I forgot a lot of things, and as I'm not going to be all wisdom and stuff like that, and then say practice makes perfect. But that is the same thing here. You need to just get used to the language, and if you have any doubts, just uh, take a look at the internet. As you know, all the answers are there on the internet, and I specifically used the overleaf.com for all of this content here. So I highly recommend anyone who's new to this program to check out that website. I'll link that in the chat channel as well. So Pugad, are you there? Pugad?
Uh, okay. Let me start off first of all by just giving you guys a brief of the different websites that Rishi mentioned and telling you bits and pieces of how it helped me. And then I'll sort of dive into the different document types that are prominently used by people. Okay, so first of all, Overleaf. He talked a lot about Overleaf. So Overleaf is this one website where you can it's basically an online tech editor, but also it's got some really neat LaTeX documentation as well. So you can refer to this one. This is what Rishi was talking about, overleaf.com/learn. Again, we will be putting all of these links in the description, so do not worry about it. But a very good quick start guide. And in fact, I have probably copy-pasted code from here more times than I can count. And the next one is tech.stackexchange.com. So it's just Stack Exchange for LaTeX, and you can just put up your questions, or you can search for the particular thing that you're looking for, and it most likely has an answer already. I have never put up a question here because most of my questions are already answered, and they have pretty standard answers because it's a very old Stack Exchange. This one is pretty well established. It's got a lot of members since a lot of people use LaTeX. So any questions, you can head to tech.stackexchange. Anytime you want to do something interesting, for example, Rishi talked about the TXZ package, which lets you do a lot of interesting things, which is you can do circuits, you can do Feynman diagrams. Well, we did a talk on geometry a couple of months back, and the paper that was so visual, all of the diagrams were done on TXZ. So, anything, any piece of drawing is possible natively on LaTeX. I usually head here when I need to find something specific. For example, I can search for packages here. I can search for them, or I can search for documentation for packages. So they've got a README, they've got a manual, and sometimes it even lets me message the authors of the package, and this is all open source, of course. So this is a very interesting sort of community to keep in touch with. With that being said, I will now go on to talk about the different document types. So there are at least 3 distinct types. So you've got, this is called Beamer, which is your, it's basically a PDF. It always, but this is like your PowerPoint, essentially. And then you've got article. So let me just show you a preview. This is the article, and if you've seen papers in RZIV, it's literally the same format. And you can have handouts or even books. So this is a book. It's a slightly beefed up version of the article template. Fun fact, this is the same template that's used by Jacob Zwischenberg, who's a pretty cool physics author. Check him out if you have time. Let me start with the article because I think it's very easy to grasp things over there. Essentially, just like Rishi said, you've got sections and subsections, and your contents are auto-generated based on your sections and subsections. For example, introduction is a section here, and when you just type /table, auto-generated. So you needn't really worry about it. And in fact, I could comment out this date, and if I render this again, it would automatically render to today's date as well. It's just taking a little time to render. Sometimes it does that, by the way. Don't get freaked out. It's just taking time. But anyways, let me stop it. Let's not spend too much time there. So the simplest article is basically designed for writing or small handouts that are used. So you have sections, you have subsections, and you have subsections. That's just the hierarchy. And of course, this looks in a particular way, right? This is centered. You have a particular type of line spacing here. All of this stems from the template that you're using. Okay, you can use a completely different template that looks different, but you can still use the same commands. You can still use section, subsection, and all of this stuff. It's very common for every template because at the end of the day, they're all using the same framework. And if you want to tweak your line spacing and so on, it's in the preamble here. Honestly, I have never tweaked it in my entire existence. I would just run with the template because it's standard most of the time. But if you want to tweak something, you can go ahead and do it here, or you can just search it up on the Stack Exchange or Overleaf if need be. And of course, so the starting point is usually you'd have a begin abstract over here, and then you'd have the abstract, and then you would sort of follow up, and then the rest of the things would follow up. That's the general sort of way in which it's arranged, and it's pretty much the same thing, as to what Rishi was explaining. You have sections, subsections, and you have all these different elements like lists, tables, and so on. And you will, at the end, you'll have bibliography, which I will sort of talk about in depth later on. So this is essentially the format of a article, and we use it generally for papers or handouts. So what do I mean by a handout? So if you're taking a course or something and your faculty gives you an assignment, they usually give not this exact form, but they probably use a similar template. So you just start the document, make the title, and head for sections and subsections and so on. And this is just an alteration. This is a this is a remodel of this template. It's called the Tuft handout style, probably one of my favorites, because I don't know, it just looks really neat to me. And the fact that all of the footnotes, which you put /footnote, you use this /footnote command next to any sentence or any other environment, it would sort of pop up in the right corner. And you can also embed images here, and you can do a lot of stuff. You can embed citations as well. So here they've embedded some images, and yeah, you can play around with it, and it's pretty cool. I'll link it up in the description. Highly recommend this. Next, I'll talk a bit about the book, because it's just a hyped up version of the article. Well, you just have two more levels when you're using a book. You have chapters and then you have parts. So your chapters are basically, so you have /chapter and then you have a chapter title. Yeah. So, okay, it doesn't seem to be working. But yeah, so essentially the hierarchy is that you have a chapter, and within the chapter you can have sections, subsections, and the same article hierarchy follows there. But you can group up chapters and you can call them parts. So you can put /part, like \part, and within the flower brackets you can type out what you want the title to be, and /chapter you can type out. So if you don't mind, let me actually open up something. Try to open something that I work on usually. Okay, let me see if this works. So yeah, you can kind of see so this is a book by default. This is something that I've been working. It's just notes for TensorCalc. So this is the front matter, which is to say all of this bit and this stuff. This is all auto-generated, and these are all links. And I did none of this because I just put up sections and subsections, but it does all of this for me. So if I want to learn about bilinear forms, if I click on it, it would just take me to what a bilinear form is, or that specific section. And it works a little differently. So I have a separate text file for each chapter, and I have to include it specifically. So this is in the same folder, but I have a subfolder called chapters, and within that subfolder I have this tensor algebra thing. So if I want to open it up, I would usually just go to the beginning of it and control click on it. My control isn't working for some reason, but usually when you control click, it would open up in a separate window, and you'd be able to edit that text file separately. So this is a different text file, this is a different text file, but I'm combining them. So I can usually reference separate files. So this cuts a lot of clutter, because this is technically like a 28-page document, but it's got very minimal amount of code because it's all stuffed in here. It sort of lets you keep things at a minimalistic level. Okay, so this is it about books. Now let's head out to Beamer. Beamer is just a fancy word for PowerPoint. And let me bring up this big guy. First of all, this slide is what you call the title page or title frame, because usually these are all frames. Each slide is called a frame here. So when you type begin frame, end frame to start and close a particular frame, and then /frame title to give it a title in the very top. One thing that you might notice is Rishi's presentation was stylistically different from this. It has red and all that stuff. Well, yes, you can color it up. You can do that. It's arguably not as easy as PowerPoint, but you can just head to this section of the template and you can play around with the colors. So let me try to actually play around with it. So let me go for play. So if I render it, ideally the color should change and the format should change. So you have color just themes. So the theme would change the way your contents are aligned, and your color themes would just change the color. And clearly we do not want to be using Berkeley because I don't know, it just hurts my eyes. So let me try to switch over to something else and we can get started. By the way, you might notice that there's something in the bottom right here. So all this does is this sort of helps you navigate through the presentation. So this is just next slide. previous slide. And they instead of using the arrow keys or instead of using or clicking the buttons in your default PDF viewer, you can just click on the presentation itself. So this is it's a cool feature, honestly, but I've never used it because I just use the keyboard or the pointer. But it's up to your preference. Again, similar to the the table of contents, you type out slash based on your sections and subsections. It will auto render, and these are also linked up. I press subsection example. I would go here. And this is just a basic example of you type text within the frame over here. You will just it will just pop up at the end of the day. Bullet points, same format as here. So you put begin itemize and slash item. You will be a non-numbered list. You type enumerate and render it. It will be a numbered list. So just some quick stuff. This is not something you should remember, but you will remember when you use it after like several tries. You will become muscle memory after a point. And within a presentation, you can set up blocks of text. So you can just type slash begin block, and it would create a block. It's not visible. Some formats would usually have like a visible boundary with a shadow for each specific block. And within this flower bracket, you must put a title. And this is an interesting thing that I learned after I found out that my 70-slide presentation just didn't render. So which is, if you don't have a title for the block, you shouldn't do this. This is the wrong thing. You should instead just have an open and closed flower bracket so that it renders. Otherwise, it will not render. It will throw up an error, and you will just be like, wait, what happened? And LaTeX, you will often run into these really annoying flower bracket issues. But again, that's a property of literally every Markdown framework that you pick, JS or HTML or pretty much anything has this issue. So it's not really the framework's fault, honestly. And you can sort of have columns in this, although maybe you can throw in an image here or something. It's up to you, but you just type slash begin column, and you type slash column with you can set up widths of so when I say 0.5 text width, so my text width is technically it's from this end to this end of the frame. So when I say 0.5 text width, that means I take up 45% of it. And this is a useful measure because let's say there's no image embedded here, but if I'm embedding an image, let's say like if I was to treat this to be an image, you can actually reduce it, like resize it without sort of causing damage to the aspect ratio by just saying 0.5 text width or something. That would just sort of, it would be a ratio of that with respect to the frame. And equations, just as Rishi said, begin and align, all of those elements compatible here. No changes at all. And yeah, this is a cool way to sort of name your equations, and you can call them begin theorem. Begin theorem is really a bit of a flex. It really does the same thing as this environment or just the $$ environment. And tables. Tables are a little weird. You can have so many different ways of constructing tables. My opinion is just copy the template from like whatever type of table you want to use and just use that. This is a rather interesting one. It doesn't have lines between or in the sides. Just it's up to your preference at the end of the day. But as you can see, it's kind of similar to the align environment in the sense that the tether points are always these ampersand's. And if you want to go to the next line, you just have these double backslash, and shortcut for double backslash is Control Enter. You type Control Enter, you will get the double backslash. So that's a pretty slick one. And yeah, this is something called verbatim. You can see that it's in serif font. You just type begin verbatim and verbatim, and it will sort of render in this weird font. So usually we'd use it to cite code and that. similarly. Okay, so uncomment this. So yeah, let me try this out. So usually you open up this figure environment because it also has some interesting idiosyncrasies. So okay, so I don't, this error is popping up for me because I don't have this test file. This test file is not with me. And mind you, but it's telling me something completely different. It's telling me that not found in frame. This has nothing to do with frame. It has everything to do with this file not being with me. So if you have this error in this place, you must understand that this is what is happening. It's kind of getting used to it. It's a bit weird, I know. And begin figure, you can do a few more things actually. You can type slash centering to center it if you need to, and you can type slash caption, and this would allow you to put up a caption along with a figure number, so you can have your figures numbered and with captions and so on. And there's a little bit of things here. So one thing about LaTeX is it will dynamically sort of allocate the space for your images without you having to place it that way. So usually in Word, you're sort of always resizing images, or you're sort of perfectly putting them in places, which can be painful to do it every time. So here in LaTeX, it automatically adjusts it. So you just open up this square bracket, close it, and there are a bunch of letters, not sure which ones they are, but if you type H, which I generally use, it just means put the figure here. You will basically, even if there's not enough room for the image, it will sort of crunch the image there, but push away every other element. Okay, so it dynamically allocates spacing, is what LaTeX does. There are a few more options like put the image where there's space, put the image where there's too much text, or move things around. You can look it up in Overleaf, or if you guys want to, I'm willing to explain it later on. But it's not really a high priority, but it's more of a interesting tidbit. So if you run into trouble with images, you would want to sort that out. And again, here in the include section, you can see that 0.8 times line width, which is to say, take 80% of the width of this frame. So it's again, it's defined as a relative measure. So I'm just going to comment it out. Again, coming to, and we'll get to bibliography right now. There's not really much more to say about presentations. But I think before that, questions, like shoot them away. Anyone with questions? Any suggestions? Anything that needs more clarification? Guys? Okay. So let me talk a bit about bibliography, and then maybe we can have an extensive discussion. But so start off with, so you have this begin bibliography thing. This is very archaic, by the way, the one we have in Beamer. The one in article is more friendly, which I'll talk about in a minute. But in Beamer, it's like you type /bib item, and each bib item has something that's called a key here. So this key is P1. And so if I want to cite this particular piece, I would just type /cite P1. Okay. So /cite P1 is what would, and it would pop up as Smith, 2012, because that's the short thing that I gave for this particular piece of article / thing. And obviously I have 3 columns here, and more if I want. I can add a new block and say /new block and add some stuff here. It's totally up to me. But to do this for every piece of reference can be daunting, honestly. It's just maddening. And the reason is because it does not support Bibtex, so you have to insert it manually. And I'll talk about Bibtex in a moment. But essentially, this is how you do it. You put it up here, and you just put /cite. Talking about things similar to this, I can actually do something cool here. So let's say not. Yeah, I can actually label sections with a particular key similar to this. So I'll just type K1 for me. And later on, I can refer to this particular image or this particular thing by typing /ref and that particular key. And since Text Studio is a pretty good, ideally, it will sort of autofill for you. So I can reference components across the presentation, and it will link up. So yeah, this is pretty interesting, some fun stuff. Let me dive into bibliography right now. So with articles, it's more interesting because you can. So I'm going to talk about something that's called BibLaTeX, but there's two other things that are called LaTeX and Bibtex. Not very different from this, but it's got some less or more features. That's all. But BibLaTeX is the most widely used one. Run with that for today. So in my preamble, I should state use package BibLaTeX so that the package is included. And I should actually add what's called a Bib file. So actually, this Bib file, which is sort of given here, add Bib resource, it actually has everything sorted out. And you can see that this is an article type and this is what would be cited. This would be the short cite thing. That is to say, if I put /cite, this is the word that would pop up. And this is all the details about it. And you might wonder, isn't this cumbersome to type out? Isn't this just so annoying? Well, actually, no, because of two reasons. One is if you're going to, let's say, cite something from the archive, I don't know, let me pick up a paper. Let's say Gauge. Yeah, that's the one. This is an interesting paper. So if I want to cite this, I can just click Export Bibtex Citation, copy, and sort of put this up here. And I can sort of pull this in, pull this out whenever I want. For example, if I want to cite what have I put this up as? So this is the keyword that I use. Haha, very long. So I just paste the keyword, and if I compile it, it will pop up as reference number 3. Yes, boom, popped up here. And it's not just the archive that supports this. You go to any, you can go to Nature or pretty much any website that hosts science articles. You will be able to generate a citation out of it, using especially a Bibtex citation. But if you do run into trouble, there's this thing called Citation Machine, which Aishu incidentally introduced to me, which is this website where I can just, hey, get me a citation. I just know that it's a book, and I know the author's name. Let's say it's Peskin. I'll just try to find that book. Certainly not all of this. Yeah, essentially, this is like a search engine for citation. Okay, let's just go with this guy. Oh boy. Yeah, this doesn't work very well on Firefox, by the way, because Firefox is actually secure. But it does work on Chrome. And it would give you a Bibtex sort of this format file, or it would give you just a proper citation for that thing in any format that you choose of. There are different citation formats for different journals and things like that. That's the vagaries of things that are available. But yeah, just pick the one that works, because it will sort of translate between all of these different types of citation. During the Pro thing, you can just watch an ad for a minute or two. Like you just go have a sip of water and come back, and you'll have access for 48 hours before another ad pops. But yeah, that's an interesting tool, and the archive themselves are sort of implementing something called Bibliographic Data, which is to say that this will show you citations. This will show you the references within this guy. So since the archive itself, you can upload text files. This is all of the citations within this paper. And you can actually go to the different versions of this documents, or you can cite them as well. So it's some interesting bits of code. And again, you can get some code out of it. Like the people in the archive have been doing this interesting. This popped up probably like 3 months back. Really interesting stuff. And if you're a developer, by the way, you can also collaborate. You can create your own tools, and you can put it up in this tab of the archive. That's possible as well. But let me get back to bibliography. So I have this Bibtex file. I just import it and I just cite it. The reason people use this generally is because I can copy paste this thing from the source, and it does put all of this mess in this one file. And my original file, the file that I usually work with, is more cleaner. And that's pretty much it as to how you deal with Bib LaTeX. It's pretty much a similar LaTeX or LaTeX. Well, you'd be just importing a file and so on, but I think this format varies and the way you cite it varies. But again, I would strongly recommend that you use Bib LaTeX. I'd like to conclude here because I think I've sort of covered some ground. I'd open it up for questions and so on for me and Rishi. And thank you for staying in the tutorial. Yep, listening in.